Problem 5 that inadvertently got omitted when I edited the document I distributed in class, but you have that. It's under sample test 2 or version 2 on the email I sent you, is to graph this equation. And you're told that this equation is a circle, but on some problems you might not be told that it's a circle. You need to recognize that. And if you understand how to get the equation and how to proceed to put this in the standard form of a circle, you'll probably recognize it. It's going to have an x squared, it's going to have a y squared, and they're both going to have the same coefficient, most likely 1, but I won't guarantee that. And then you're going to have an x and a y term and some other stuff. So to graph the circle, we complete the squares. On x squared plus 10x and y squared minus 8y. Having completed the squares, we'll be able to write this as x plus or minus something squared plus a y plus or minus something squared equals some other number over here, and this number will be the square of the radius, and the numbers that we get with the x and the y are going to give us our center and radius. So we'll get to that, but let's go ahead and complete the square. Okay, x squared plus 10x plus what is a perfect square? Well, the method you're given is the question mark equals the square of half the coefficient of x, provided the coefficient of x squared is 1. And that's the case here. Coefficient of x squared is 1, so we can just take half of the coefficient of x, square it, that replaces our question mark. Okay? So our question mark is going to be half of 10 squared, which is 5 squared, which is 25. So what do we do with that? X squared plus 10x is equal to x squared plus 10x plus 25 minus 25. Because, of course, adding 25 and subtracting 25 is the same as not doing anything at all, because that comes out to be 0. So if we simplify this, we do get x squared plus 10, so it's clearly plus 10x. So now it's clearly equal to this expression. But this expression can be written as x squared plus 10x plus 25 minus 25. There's no change there. And then this can be expressed as the square of x plus 5. So x squared plus 10x is equal to each of these expressions, but most importantly to x plus 5 quantity squared minus 25. Okay? Now similarly, if we follow the same steps, and I'm not going to take up time here to do that because I assume that you can, but if you can't, please submit a question form. Y squared minus 8y can be written as, well, half of negative 8 is 4, square that, you get 16. So we can write that as y squared minus 8y plus 16 minus 16. Again, the 16 comes from taking half the coefficient of y and squaring it. The coefficient of y squared is 1, so it's valid to do that. And then if we go through the factoring, we're going to get y minus 4 quantity squared minus 16. And if you don't see those steps, you should probably go back and review factoring a little bit. and review some of the Chapter R material that leads into this. If you're going to retake a Chapter R test, Chapter R and 1 test, that would behoove you anyway, because you could probably pick up some points that way if you don't understand this. If you get to where you do understand it, you're going to get more points. You're probably going to do better on a problem of this nature. Okay. So, x squared plus 10x plus y squared minus 8y equals 8 gives us, well, I'll say it's equivalent to, we replace x squared plus 10x by x plus 5 quantity squared minus 25. Y squared minus 8y by y minus 4 squared minus 16. And the equation becomes this. The x plus 10x is this. The y minus 8y is this. And now we can simplify the equation. We can say that's the same as x plus 5 squared plus y minus 4 quantity squared. And then minus 25 and minus 16 is negative 41. We add 41 to both sides. We get 41 plus 8, and magically that comes out to 49, which is a perfect square, which is cause for some joy. So now we have the standard equation of a circle, because this says the distance from negative 5, 4 to xy, the square of that distance is 49. So the distance from this point to this point is 7. Now the locus of points, if we have the point negative 5, 4, and we have a point here at distance 7, well, that point is just part of a circle of radius 7 about this point. So it's the graph of the equation is the circle centered at negative 5, 4 radius 7. And just to be abundantly clear about that, at this point out here in the circle, and this could be any point in the circle, if this point is xy, let's draw a little line there to separate the picture from the calculations up here. If this point is xy, this point is negative 5, 4, then we can form this triangle. And what are the sides of this legs of this triangle? Don't have room to label them here, so I'm going to bring the triangle down here. And I'll give myself a little more room over here. Okay, so here's the triangle. Here's the point negative 5, 4. And here's the point xy. Wall that off a little bit. So the run is what? X minus negative 5. That's x plus 5. And let me make sure that's still in the picture. Things are getting a little jumbled down here, but let's deal with it. And the rise is y minus 4. So the hypotenuse, I'm going to have to grab a little more room up here. is the square root of x plus 5 squared plus y minus 4 squared. Bad planning here. You probably can't read what I wrote there, but you should be able to work that out. It's going to be the square of x plus 5 and the square of y minus 4, because the hypotenuse is the square root of the sum of the squares of the legs. This leg is x plus 5, so we square that. This leg is y minus 4. We square that up here where you can't read it. And we get that the hypotenuse is this. And the hypotenuse is the distance from here to here, so that's got to be equal to 7, so that this equation represents this circle.